Okay. Good afternoon, everyone, and welcome to this afternoon's seminar. The speaker today is Dr. Nathalie Seddon. Nathalie has been in Oxford about a decade. She came here as a Royal Society University Research Fellow in 2005, appointed Associate Professor in 2009, and became Director of the Biodiversity Institute and therefore joined also the Oxford Martin School a couple of years ago, the Biodiversity Institute being one of the 30-odd institutes and programs linked to the Oxford Martin School. Nathalie is also a Research Associate of the Center for Tropical Research at the University of California in Los Angeles and a Research Associate of the Smithsonian Tropical Research Institute in Panama, and also a Fellow in Biology at Wadham College, the other side of the King's Arms. So she's got the globe covered. Her research combines global comparative analyses with experimental field and lab studies to address three key questions. How do lineages radiate into multiple species? Once species are formed, how do they interact and assemble into functioning communities? And then, how can these insights help us to formulate effective strategies for conservation and sustainable development? So she's the perfect person to address today's topic on what happens when we turn up the heat on nature. So I'll hand over to Nathalie, but before I do, if you can come, I just want to warn you that Nathalie hasn't heard herself speak for a week because she's lost her voice. It has come back today to an extent, but we'll just have to bear with her if she has problems later on as the talk progresses. Thanks, Nathalie.
Okay, thanks very much, Julian. And thanks very much to the Oxford Martin School for the opportunity to speak today on what the impacts of climate change are on biodiversity. So let's start with some facts about the Earth's climate. It's warmed by approximately 0.74 degrees over the past 100 years, with two main periods of warming, one between 1910 and 1945, and the other from 1976 onwards. And the rate of warming during the second period was double that of the first, and greater than at any other time during the past 1,000 years. And 2014, as you may know, was the hottest year since records began. Now, notwithstanding year-to-year stochasticity, the temperature is continuing to rise. And according to the latest IPCC reports, global mean temperatures are predicted to increase by a further 4.3 degrees by the end of the century. Now, as a result of this warming, our ice caps are melting and sea levels are rising. And we're seeing more freak storms, flooding, crop failures, and droughts. Clearly, climate change spells chaos for people. But what about biodiversity? Obviously, this is bad news for the polar bear. We don't need any fancy or sophisticated science to tell us that the melting ice caps are disastrous for him. But what about the other 9 million or so other distinct species and lineages with which we share the planet? What are the implications of climate change for that biological diversity? For this biodiversity that took approximately 4 billion years to evolve and that makes our planet utterly unique. So there are several ways in which individuals, populations, and ultimately species can respond to systematic environmental change. They can alter their behavior. In particular, they can breed at a different time or place. They can move or track their preferred niche across space and time. They can adapt, in other words, evolve to survive and reproduce under a different set of ecological conditions, or failing that, of course, they can go extinct. So in this talk, what I want to do is briefly review the evidence that species are in fact responding in this way. And how I will ask, how do we know that it's climate change that's causing these responses? And then I will ask, does it matter if a species changes when they do things, if it moves or adapts? What's all the fuss about? If a few species go extinct, does it really matter? After all, extinction is part of evolution. So I will talk about why a failure to adapt or move matters, and I will discuss why extinction matters. In the second half of the talk, I want to focus on solutions, and I want to emphasize the central importance of forest, in particular tropical forest. And I want to persuade you that the answers to many of our problems and many of the 21st century challenges we face lie in protecting our forests and I want to persuade you that that is achievable. Okay, so by far, most observations of climate change responses have involved alterations in species phenologies. So that is timing of key life cycle events, things like fruiting, flowering, migration, and so forth. Now, planting dates, harvest dates, the day of the first frost, have been well recorded for hundreds of years, actually, for obvious agricultural reasons, and have, for a bunch of sociological reasons, records of the first signs of spring. So the first leaf on an oak, the first butterfly seen flying, the first snowdrop in bloom. North Europeans have, in particular, been obsessed with recording all these details for many, many years. So the longest records of direct observations are for flowering of cherry trees in Japan and for grape harvests in Europe. Timing of cherry blossoms in Japan has been highly variable among years, but there were no clear trends seen between the 1400s and the 1900s. A statistically significant change point is seen first in the early 1900s, and there has been a steady advancement since 1952. Meanwhile, grape harvest dates across Europe are explained by April-August temperatures, and in the 2003 heat wave stands out as an extreme early harvest, records going back 500 years. And now these lengthy observation periods in these two unrelated plants on different sides of the globe add an important, a crucial, I would say, historical perspective to the results that we now analyse over much shorter time frames. So a large number of studies in Europe and North America have revealed changes in the timing of key life history events that reflect responses to climate change. Common are changes in the timing of spring activities, including earlier breeding, the time at which the birds first start singing, earlier arrival of migrant birds, and so forth. And studies in Europe and North America since the 1960s have shown that many species are now breeding between 8 and 10 days earlier, with migrant birds arriving on average between 1 and 3 days earlier on their breeding grounds per decade. Similar sorts of findings have been reported in a large number of amphibian species, particularly detailed studies in Canada, showing that a number of different amphibian species are chorusing and spawning considerably earlier, ranging, depending on the species, ranging between 19 and 38 days earlier now, compared to the 1970s. Now, butterflies, for obvious reasons, also show high correlation, high relationship between the date of first appearance and spring temperatures. So it's not surprising that their first appearance has advanced for almost all species in the UK, all species analysed in a study in Spain, and a fairly comprehensive study carried out on butterflies in California, showing that 70% of species have advanced their first flight date by as many as 24 days. So with general warming trends, climate envelopes become shifted towards the poles or at higher altitudes. Now, to the extent that dispersal and resource availability will allow, species will track shifting climate and shift their distributions poleward in latitude and upward in elevation. And there is some very good evidence that certain species are on the move. So there's some evidence that the range of sea ice dependent species in the Antarctic are changing, many of them contracting. Meanwhile, there are other studies show actually the expansion of ranges of other species, so of open ocean species. Various species of penguin, including the chinstrap penguin, have expanded their ranges as the extent of the ice cap in Antarctica has contracted. There's also many studies now showing that butterflies in particular, but also a range of dragonfly and bird species, are tracking their preferred climatic niches, which generally involves a movement north. So you'll see on the slide here, 50% of European birds, butterflies and dragonflies have shifted their ranges considerably since the 1970s. We're also seeing increasing colonization of the temperate zone with species from subtropical zones. Meanwhile, in the mountains, we now have fairly good data, collected over fairly long time frames, several decades anyway, from the Alps, the Andes, and the Himalayas, indicating that taxa are moving upslope, so indications that tree lines are moving upslope. And for example, that the ranges, the breeding ranges of many bird species in these mountain ranges are also moving upslope, and that species that generally breed in the lowland tropics are increasingly found to be breeding in the submontane zone. So what do this collection, arguably just a handful really relative to all biodiversity, a handful of studies tell us about the impact of climate change? How can we attribute these changes in phenologies and ranges to climate change? Well, any underlying signal from climate change is revealed by a systematic or diagnostic trend across diverse species and diverse geographical regions. So in a very well-cited study by Parmesan and Yo, published in Nature just over a decade ago, that showed that studies from, well, what's now over 2,000 species actually have shown that recent trends match climate change predictions. In other words, movement upslope, movement north, earlier arrival at breeding grounds, earlier singing and spawning and so forth. And a global meta-analysis had documented changes of that sort in over 80% of the species studied. So where shifts averaged 6 kilometers per decade towards the poles, spring advancement of around 2 to 3 days earlier per decade. And as I say, these studies have been found on every continent, every ocean, and in most taxonomic groups studied. Now in this study, they defined a kind of a diagnostic fingerprint of sign switching responses uniquely predicted by 20th century climate model trends. And among appropriate data sets, so for 279 species for which there were sufficiently detailed long-term studies, they were able to demonstrate these diagnostic shifts, so a shift in a trend attributable to climate change. And this suite of analyses and other analyses that followed it have generated very high confidence, as defined by the IPCC, that climate change is affecting these living systems. Now, if plants and animals can simply move, or if they can simply change the timing of key behaviours, what's the problem? Isn't climate change actually part of the natural order of things, and species have for a long time had to adapt and evolve? Well, there are various issues with this. Well, species are not islands. Most species, as you will be aware, interact with a whole load of other species, predators and prey, hosts and pathogens, parasites and so forth. Now, not all members of those often very complex webs of interactions can move at the same rate. You know, species differ in their physiological tolerances. They differ greatly in the extent to which they can disperse. And so more crucial than any absolute changing in timing of a single species is the potential disruption of coordination in timing between the life cycles of predators and prey, of herbivorous insects and host plants, of parasitoids and their host insects, and perhaps very importantly, of course, insect pollinators and their flowering plants. And so there are all sorts of studies which have shown these sorts of disruptions. For example, there is good evidence that warmer springs in Europe has disrupted the synchrony between winter moth hatching and oak bud burst, leading to a fairly major mismatch between the peak in insect availability and the peak in food demands of the great-tit nestlings. Other examples of well-documented mismatches are mismatches between phytoplankton and zooplankton blooms in lakes. And in one study, a greater synchrony that thought to be the result of climate change actually led to the distortion of a sex ratio in the population of butterflies, because the parasite leading to a new parasitic interaction. Another critically important example of this, with fairly major global consequences, is the mismatch in timing between the big phytoplankton bloom, shown here, and the appearance of krill in the Southern Ocean or other key members of the zooplankton assemblage, with implications clearly for survival and breeding in whales, which perform major ecosystem functions. So the warming and the acidification associated with climate change has really produced much lower productivity of phytoplankton, which is at the base of the food chain in the Southern Oceans, and as well as influencing the composition and the timing of these phytoplankton blooms, with a major impact on the productivity of fisheries. But even if all members of a web can move, and this sometimes happens, there might not be anywhere to go. Now, this is most obviously a problem in the mountains where populations could potentially just disappear off the top. Meanwhile, the modern landscape provides very little possibility for species to adjust to rapid environmental change. Species in many areas of the world today must navigate through a landscape that has been profoundly impacted by human activity and rendered, as a consequence, largely impassable. Now, as a result of widespread loss and fragmentation of habitats, many areas which may become climatically suitable with future warming end up being remote from the species' current distributions and beyond their dispersal capability, for example, ultimately resulting in increased extinction. So if species can't move, either because they have low dispersal capabilities, or because the other species that they depend on can't move, or because there's nowhere to go, then why aren't species adapting? Why doesn't evolution come to the rescue? Now, there is some evidence of this. There is some evidence, some very nice studies in coral reef species, for example, and in a range of studies on mammals, frogs and fish, for the evolution of new physiological tolerances under climate change. In particular, it has been reported across a large number of taxonomic groups that many plants and animals are shrinking, that they have lower body mass. The mechanism is not entirely understood, but it's thought to be linked to nutrient limitation under climate change and higher metabolic rate, both of which select for smaller body size. Now, recently there was a very nice study addressing the capacity of evolution to come to the rescue under climate change, which was looking at phylogenies, well-resolved phylogenies, so phylogenies that show the evolutionary relationships within 17 different groups of vertebrates. And they mapped climatic niche traits onto these well-resolved phylogenies, and using that we're able to calculate rate of climatic adaptation. And what they found, to cut a very long story short, was that rates of evolution on the whole are around 10,000 times too slow to keep up with the rate of climate change. So no, evolution, I don't think, is going to provide any meaningful help. So what is the evidence, though, that climate change is causing extinction as a result of these processes? Well, the first extinctions attributed to climate change come from mountain-restricted species, and no surprise there. And a shocking 67% of harlequin frogs in Central and South American forests have disappeared over the last 20 to 30 years. And the reason is very interesting biologically, in the sense that this is thought to have been a result in the shift of the mid-elevation sites where the preponderance of extinctions have occurred into thermally optimal conditions for a fungus, the tritrid fungus, which is actually directly responsible for killing these amphibians. So warming has brought this fungus into the range of these amphibians, and the amphibians have consequently gone extinct. The other major victims of climate change so far are corals, elevated sea surface temperatures, and much stronger El Niño, southern oscillation events associated with global warming have been strongly implicated in the bleaching and loss of a large number of coral species. So, for example, there was a particularly strong El Niño event between 97 and 98, caused bleaching in every single ocean. 95% of corals were bleached in the Indian Ocean, for example, and ultimately this resulted in 16% of coral species becoming globally extinct. But let's put some of these figures into perspective. According to a recent report, so this is a report published in Nature in mid-December, which was an analysis of the latest IUCN Red List, current rates of extinction lie somewhere between 10 and 690 species per week. And we face losing over 26% of mammals, 13% of birds, and 40% of amphibians by the end of the century, with unknown but potentially very high levels of extinction in much less well-studied groups, such as deep ocean organisms and in invertebrates. What's causing those threats? Climate change really is just one of several major drivers of current and predicted extinction. In fact, to date, climate change is estimated to be contributing to around 7% of species population declines Currently, much more significant drivers of population declines and extinction are overexploitation, habitat degradation and change, and habitat loss. Now, these are, of course, all linked to human population growth and increases in per capita consumption, and hence are only likely to get worse. So this is clear that climate change is happening, and there is good evidence that it is affecting the abundance and distribution of plants and animals, their phenology, and it has resulted in some extinctions. But the impacts are not yet fully felt, so much of the science here is in the area of prediction. Now, over the past decade, some of our understanding about the variable and complex ways in which species respond to environmental change has been effectively translated into mathematical models that can be used to forecast climate change, impacts on species distribution, abundance and extinctions. These models are characterized by high diversity of underlying structures and assumptions, and the predictions differ greatly depending upon the species studies and so forth. However, most of these models indicate that climate change will be the major future source of extinction, especially acting in synergy with things like land use change. And recent models, the IPCC, predicted that around 20 to 30% of species are at high risk of extinction under between 2 and 3 degrees of warming. Now, a very recent model, published just a few weeks ago actually, predicted that around 60% of plants and 35% of animals are likely to lose over 50% of their present range by 2080. However, with mitigation, losses are reduced by 60% if emissions peak in 2016, so next year, or 40% if emissions peak in 2030. In other words, without mitigation, we risk precipitating the Earth's sixth mass extinction. So the sooner we act on climate change, the better for biodiversity. But how critical is the current and predicted loss of species? Does mass extinction actually matter? Why it matters has been studied for a very long time and is captured in this very simple diagram. It matters ultimately because our health, wealth, and well-being depends critically on natural systems. We know that nature and the ecosystems that harbour genetic species and habitat diversity and perform essential functions such as biomass production, carbon storage, decomposition and nutrient cycling. And we know that our activities are compromising the ability of Earth's systems to perform these functions. Now, these sort of functions and services produced by natural ecosystems were first sort of properly or formally delineated and visualized as part of the Millennium Ecosystem Assessment, which was carried out in 2005. Now, and it basically categorized all these functions and services that nature provides us into these 4 different sorts: supporting, provisioning, cultural, and regulating. Now, since the Rio Summit in 1992, a huge body of research aims at testing the links between nature, and particularly the links between biodiversity and species richness and these ecosystem functions and services. Really, this was a huge area of industry and biology, and was actually one of the fastest growing areas over the past 20 years. Now, there's lots of important science still to be done in showing the mechanistic links between biodiversity and ecosystem functions and services. But after thousands and thousands of experiments and modelling procedures, there is a general consensus now that biodiversity loss reduces the efficiency by which ecological communities capture resources, produce biomass and so forth. That the loss of biodiversity decreases the stability of ecosystem functions through time. That the loss of diversity, particularly across trophic levels, influences ecosystem functions particularly strongly. And that actually the impacts of biodiversity loss on ecological functions rivals the impacts of other major global drivers of environmental change, such as pollution and habitat degradation. So, climate change is going to be a major driver of biodiversity loss, especially when it interacts with other drivers of change, such as land use change. And the loss of biodiversity is a major problem for humanity. What is to be done? And so I want to spend the next half of the talk focusing on some solutions. And in particular, I want to, as I say, emphasize the importance of forests in general and tropical forests in particular. And I believe that in focusing our efforts and conserving forests, we will go a very long way towards meeting the twin 21st century challenges of climate change on the one hand, and strongly interrelated with that, biodiversity loss. Okay, so tropical forests cover only 2% of the Earth's surface, yet they harbour at least, probably way over 50% of our biodiversity. So this is a beautiful graphic which I show a lot in my talks. I think it's really, really striking, which shows species richness mapped in terms of the diversity of birds, mammals, amphibians across the globe. And showing this pattern that we're all very familiar with, increasing species richness as you travel from the cool poles to the warm tropics. This is another map, looks rather similar, doesn't it? This is not for biodiversity, this is for carbon. So not only do the tropics hold over 50% of the world's biodiversity, they also store over 50% of the Earth's carbon. Tropical forests are very, very important in regulating climate. So a new study published just last year showed they're actually a lot even more important than we thought they were, and they're responsible for absorbing 1.4 billion metric tons of carbon dioxide from the atmosphere a year. This is over half the total absorption, so they're a phenomenally important role there in regulating climate. However, rates of habitat loss and modification are highest in the tropics. All these things come together in the tropics. 9 million hectares of forest were lost only between 2009 and 2012. Now, the highest rates of loss until very recently were found in Brazil. Clearly, Brazil encompasses the majority of the world's tropical forests. Very worryingly, Indonesia, very recently, last year, in fact, Indonesia overtook Brazil in terms of its rates of deforestation, despite only having a fraction of the forest cover. And some recent work has shown that 30% of the timber and paper products coming from Indonesia is illegally traded. A lot of that going to China, Europe, and United States. Okay, so here is an image of forests, rivers and forests in my favourite part of the world, Amazonia. Now, again, we don't need any sophisticated science to tell us that converting this to this is very bad for biodiversity and probably very bad for carbon too. But actually, whilst total clearance of tropical forests is obviously a major concern, more pervasive is habitat degradation, so is the conversion of primary forest to secondary forest through logging. So 20% of tropical forest is degraded. Now, until recently, the general consensus was that if you lose a handful of species through the conversion of primary forest to secondary forest, then this doesn't really influence the forest's overall functionality. However, the bad news is that there is growing evidence that the loss of small proportions of diversity have a high impact on their functions. Not all species are equal in terms of their contributions to ecosystem functions, and some recent work in our lab has indicating that in Amazonia, at least, if you remove 30% of the large trees, you lose the large-bodied fruit disperser and hence limit the capacity of forests to regenerate in the long term. So even forest degradation is bad news for biodiversity. Of course, forest loss results in the release of all that stored carbon. So forests are very important in that they store the carbon, but they become very dangerous when they are degraded or deforested because they will release that into the atmosphere. So here is the latest global carbon budget, which indicates that around 10% of CO2 emissions come from land use change, and the majority of that comes from deforestation in the tropics. Now, not only does forest loss result in an enormous amount of CO2 being released into the atmosphere, it massively disrupts the flow of water in the atmosphere, and it influences local ambient temperatures. For example, in a single day, the Amazon region evaporates 20 billion tons of water. Compare this with the mere 7 million tons of water that the Amazon River discharges each day into the Atlantic. Now this generates respiration process generates what has been termed flying rivers, vast flying rivers, clouds above the Amazon on which the Amazonian region's agricultural productivity depends and on which Brazil's massive urban populations depend. Now, following a huge spike in deforestation in the Mato Grosso region in 2013, satellite imagery clearly showed that during January and February this time last year, those flying rivers simply failed to arrive, unlike the previous 5 years, leading to Brazil's worst drought ever, an ongoing drought, an ongoing major problem that's having a huge impact on the Brazilian economy. But tropical deforestation affects weather and agriculture globally too. So a recent synthesis of global climate models revealed powerful evidence that deforestation in the tropics can trigger major shifts in rainfall and increase temperatures worldwide, and finds that future agricultural productivity at the globe is at risk of tropical deforestation. So in basic terms, an increase in temperature in the tropics due to deforestation generates a large upward movement of air into the upper atmosphere. When they hit the upper atmosphere, they call ripples, referred to as teleconnections, that flow outwards, and the common analogy used being like an underwater earthquake that can generate a tsunami. Now, these models of the study examined show that increased or complete deforestation could seriously adversely affect some of the world's most important breadbaskets. For example, complete deforestation of the Amazon basin would reduce rainfall throughout the US Midwest, Northwest, and parts of the South during the agricultural season. The complete deforestation of Central Africa would cause declines in rainfall in the Gulf of Mexico, in US Midwest, Ukraine, and also in Southern Europe. So clearly, the key way to minimize climate change, to save biodiversity, and to retain ecosystem functions on which we depend, and thereby elevate per capita wealth, health, and well-being, is to conserve forests, especially in the tropics. But how can this be achieved? Well, to figure that out, we need to consider what the main threats, what the main drivers of tropical deforestation are. So the majority of tropical forest loss and degradation is driven by the production of just a handful of globally traded forest risk commodities, namely palm oil, soya, beef, leather, timber, pulp, and paper. So these graphics are from the Amazon region, and this is looking at the pie chart shows that between the year 2000 and year 2005, most deforestation was attributed to cattle ranching and small-scale agriculture. Now, since then, during that period, beef production has stabilized in the Amazon, but soy production has increased massively. And so that pie chart looks rather different now. Most of deforestation in Amazonia is being driven by soya bean production and more recently by palm oil production as well. So palm oil, as you will know, is found in an increasing number of products we use daily. In fact, it's hard to identify something that we don't interact with regularly that doesn't contain palm oil. And the global production of this vegetable oil has increased exponentially over the last 50 years. Now, until recently, this was mainly produced in Indonesia and Malaysia, where vast areas of tropical forest, primary tropical forest, have been converted into palm oil, with negative consequences clearly for biodiversity and for the release of carbon into the atmosphere. But the concern now, quite recently, is it's spread into West Africa, particularly Cameroon and the Congo, where this recent study is sort of flagging up the potentially dire consequences of this expansion, unregulated expansion, for things like primate diversity, which peaks in West Africa. So these kinds of commodities, beef, soy, palm oil and paper products, the production of them is obviously bad for biodiversity in that much of it is produced in tropically forested regions. But what are the direct impacts of the production of these commodities on carbon dioxide emissions? Well, the impact through deforestation has recently been quantified and is summarized here for the top 4 commodities. Now note that this graphic is just for commodities produced by Argentina, Bolivia, Brazil, Paraguay, Indonesia, Malaysia and Papua New Guinea. Now we can see, looking at this, that the biggest carbon footprint is beef production in Brazil. By far and away, the commodity that produces the most carbon dioxide. Seconded, most of that Brazilian beef is destined for the EU and China. The second biggest carbon footprint is wood products and palm oil production in Malaysia and Indonesia. But again, the patterns are shifting as Africa becomes developed and palm oil starts expanding there. Well, how can we stop the juggernaut of industrial agriculture, given the huge growth in human population predicted and, perhaps more importantly, the massive growth in per capita consumption in the world? What hope is there really for slowing biodiversity loss and avoiding catastrophic climate change? Well, I believe that there are several reasons we should remain hopeful and why we should remain very active and engaged with this whole process. And in particular, there is cause for hope in the form of growing commitments at public, corporate and government levels. So I'd like to talk through some of those solutions and reasons for hope and highlight where I believe action should now be targeted. So it would seem that there is, amongst the public, for a start, there is growing will, growing desire to see a greater proportion of wild nature protected. So according to a recent study conducted by ZSL, which involved thousands of people and was conducted across several continents, it was the first sort of global scale public opinion poll of its type. And according to this, at least 40 and as much as 70% of wild nature should be protected. So people in Brazil were generally voting that at least 70% of wild nature should be protected. In the UK, this was 40%. In the USA, this is 50%. So this is terrestrial ecosystems. Very similar patterns were found for protecting the oceans, protecting the marine environment. A large proportion of those people surveyed voted for a large chunks of marine environment to be protected in perpetuity. Meanwhile, last September saw the largest demonstration for climate change, where 300,000 people descended on New York during the UN climate negotiations. Governments are also finally properly engaging. In New York City, for the first time, forest, in particular tropical forest, became a point of discussion. It became central to the talks. And over 24 countries and many other major companies signed up to the New York Declaration of Forests. The declaration being to halve deforestation by 2020 and halt it by 2030. Perhaps most encouraging were signs of engagement in reducing deforestation explicitly by the world's biggest emitters of carbon dioxide, USA and China. At COP20 in Lima, some progress was made. Perhaps most importantly, 8 Latin American governments pledged to restore over 20 million hectares of forest. Many more countries committed to contributing to the Green Climate Fund. And though many mainly diplomatic obstacles remain, and there is much work to be done over the next few months, there are signs that something at least close to a globally binding treaty on emissions will be achieved in Paris. The 86-page Geneva blueprint, which has been the product of years of negotiation, does seem manageable by comparison to the highly contentious 300-page version that was produced in Copenhagen. and it represents the first ever proposal with buy-in from all the world's nations. It's a long way to go, but there are definite signs that something good is going to happen in Paris. Finally, there is action of certain individual governments, a cause for a great deal of hope and motivation and inspiration. Last month, Colombia's president, Manuel Santos, announced a plan to establish the world's largest protected area, covering an area apparently that's going to be almost 4 times the size of Germany. It's going to be a transnational, transboundary one, which is involving buy-in from the Brazilian and Venezuelan governments, encompassing around 135 million hectares. We'll have the largest number of distinct ecosystems and support the highest number of species of any currently existing protected area, and will run from the Andes to the Amazon and to the Atlantic, a massive corridor across northern South America. Meanwhile, the Norwegian government is doing more for climate and biodiversity than any other, having given over 2.5 billion in the last 5 years in compensation for forest conservation, particularly in Brazil and Peru. So, well, we have many reasons to be a little bit cynical or suspicious of high-level pledges, because often they rarely become reality. But Brazil has really led the way. Since 2004, the nation with the world's greatest proportion of tropical forest cut annual deforestation in Amazonia by nearly 80%. At the same time, during that period, agricultural productivity and output increased sharply, and economic growth increased massively. And Brazil thereby showed the world that deforestation and economic growth can in fact be uncoupled. Establishing new protected areas, enforcing environmental laws, and various private sector measures all played a part in the decline in preventing around 3.2 billion tonnes of carbon dioxide emission, which someone has calculated is equivalent to removing all the cars from America's highways for 3 years. A huge contribution to global climate. Now, although the relaxing of the soy moratorium has resulted in an increase in deforestation recently, and it's thought precipitated this huge drought, Brazil nonetheless revealed to the world what is possible when governments fully engage. And the credit for this process is shared by many. Marina Silva, as minister and presidential candidate, played a huge role in this. The NGOs, the large number of NGOs that generated the moratorium on soy and also beef industry, and the massive financial compensation provided by Norway showed Brazil that the international community, or at least one part of the enlightened part of the international community, was prepared to support them for conserving their forest. Mainly, however, it is change in policy that made this all possible. And for this, Brazilian civil society really deserves most of the credit. Rubber tappers, labour organisers, indigenous people, environmentalists, and many members of the broad social movement to end deforestation made it possible and ultimately made it necessary for politicians and businesses to act. And they have done a great service, clearly, to climate and to the biodiversity, not just in Brazil, but of the whole planet. So another major source of optimism, I think, and in exciting developments last year, I mean, a lot of these things I'm talking about are really quite recent. As a result of sustained campaigning by various environmental groups, dozens and dozens of the world's largest buyers and sellers of soy, palm oil, cattle, wood pulp, and so forth have established policies that have committed them to excluding deforestation and social conflict from their supply chains, giving us power as consumers to buy products that we know haven't involved a negative impact on the climate, biodiversity, or other human beings. Wilmar, that controls the majority of the production and the distribution of palm oil, shown in the darkest green of this pie chart here, which shows the different companies that are responsible for the production and distribution of this oil. Wilmar was the first to commit to zero deforestation. Once it had committed, the other big players followed suit. Particularly important of these was Cargill, which sells 135 billion worth of commodities a year. and Asian pulp and paper, which is has been traditionally a major role to play in deforestation in Indonesia, Malaysia. And Rainforest Alliance recent audit of Asia pulp and paper revealed that they're actually making some moderate progress towards achieving this goal of zero deforestation in their supply chains. Okay, so greatly facilitating the process by which organisations such as these meet their targets are initiatives promoting transparency in the monitoring of supply chains. And last month, a major initiative by the Global Canopy Programme was launched, the Forest 500. I really urge you all to look this up online. This list identifies, ranks and tracks entities responsible for deforestation and exposes them to what Global Canopy refers to as a hidden deforestation economy we need to all be very much more aware of. And the assessment ranks 250 companies, 50 jurisdictions, 150 banks and 50 power brokers by the extent and scope of their sourcing policies for 6 forest risk commodities. So the rationale is that a fairly small number of power brokers across various sectors can reduce deforestation. However, there's been a lack, no system in place to track this progress towards deforestation so it can meet the New York Declaration of Forests by 2020 or 2030. So what the list reveals so far is that while a number of high-profile companies have adopted policies, and I've mentioned a couple of those, many companies still lack forest-friendly safeguards. And I really think that this type of initiative, the Forest 500, is something to watch and engage with over the next decade. Now also, absolutely key to success in governments and businesses meeting their targets is technology to map carbon and to monitor what's going on in the forest. And here we have had a number of recent, really quite mind-blowing breakthroughs which really change the landscape. In particular, we have amazing technology developed by Greg Asner from the Carnegie Airborne Observatory to map carbon quite accurately in forests. He published a map of the carbon content of an entire country of Peru. It's illustrated here. He uses advanced optical and chemical sensors in connection with light detection and ranging technologies, which basically mainly involves beaming pairs of lasers at the forest canopy. And his study revealed that 1 billion of 7 billion tons of carbon stored in Peruvian forests is an imminent risk of being lost if current plans for exploitation, logging, palm oil exploitation, mining and so forth move forward. So with this sort of technology, we can actually quantify how much carbon, much more efficiently than we have been able to do before, how much carbon is the carbon costs of certain sorts of development and commodity production. Meanwhile, there has been a proliferation in technology for monitoring. Perhaps one of the most powerful of these is an online interactive satellite image analysis platform called Global Forest Watch, which is supported now by Google and is funded through the World Resources Institute, that provides, it's a great thing to interact with, do look at it online. It provides up-to-date coverage of deforestation globally. So as an example, it recently uncovered that United Cacao, which is a London-listed company that claims to produce ethical, sustainable chocolate, had quietly cut down over 2,000 hectares of primary closed canopy rainforest in the Peruvian Amazon. The company said that the land had been previously cleared, but satellite imagery collated by Global Forest Watch told a different story. So in tandem, drones are increasingly very effectively being used to monitor logging and poaching activity and so forth on the ground. We have sensors, camera traps, and increasingly ingenious ways of using mobile phone technology. In other words, it is becoming increasingly difficult to get away with the illegal erosion of biodiversity and damage to our climate. And it is going to be possible to hold governments and businesses to their claims to minimize deforestation in the coming decades. Okay. So climate change poses the biggest future threat to biodiversity, and the loss of biodiversity compromises the long-term sustainability of humanity on this planet. There's still a lot of interesting science to be done here. However, while we're dotting the I's and crossing the T's in this area, we need to be also focusing a lot of energy on resolving the challenges involved in implementing a really key solution, in other words, protecting forest. There is hope in the form of growing commitment at public, corporate and government levels, We know from Brazil that economic growth, that agricultural productivity is possible without the destruction of natural habitats. And we have technology and also social media to monitor, to map and monitor carbon and biodiversity loss. Key action areas, what we should be doing? Well, we should be continuing to lobby for zero deforestation and lobby for transparency in commodity supply chains. And in addition, we need to be working on linking policy on agriculture, forestry and indigenous people. Currently, in most countries, these issues are dealt with through separate processes by separate organisations almost. But only an integrated approach will have long-lasting positive impacts on climate and biodiversity. The UN programme RED, for example, at the core of which is the twin importance of forest and for biodiversity and climate, has run into profound difficulties, as it has in many places run into the displacement of people dependent on forest products. This is clearly not a long-term solution. We also clearly need to be campaigning for behavioural change, in particular reducing our consumption of luxuries, and in particular, I'm afraid, reducing our consumption of meat and beef. And I would also argue that we should be campaigning to empower women in all sectors of our society, as there is increasing evidence that this will go a long way to solving many of the 21st century challenges. So the world we live in 100 years or 200 years will of course unavoidably be of human design. But let that design be the product of science and careful evidence-based changes in policy and rigorous campaigning, rather than war over dwindling natural resources. Thank you. Thank you. As much as my voice will allow, I think we do have some time for questions if anyone has any. Yeah.
Thanks. I just want to go back to one of the points you made earlier about you gave a quantity of carbon absorbed by the rainforests within a certain time period. There's been a lot of research recently to suggest that old growth forests don't actually absorb any carbon. They're carbon neutral, and in fact only new growth forests absorb any type of carbon. And so the actual contribution of carbon absorption of the rainforests of which you speak is of negligible proportions relative to the oceans, for instance. Have you brought that into your calculations?
So I'm very glad you brought up oceans. I tend to be very focused on terrestrial ecosystems, and as we know most about them, obviously the oceans absorb an enormous amount of atmospheric carbon dioxide, and huge consequences of that, and clearly a lot of future action needs to be focused at making sure we maintain the ocean's capability of doing this. I think in terms of the role of old growth forests versus sort of secondary forests and the carbon budget, those calculations are very complicated, often controversial. I think one of the biggest problems is that the deforestation of old growth forests results in the release of a lot of carbon dioxide, and that's one of the main issues. In terms of absorption of carbon dioxide, sure, at the moment the figure is something like 10% or 10 to 30% of carbon dioxide emissions are absorbed by natural habitats. But there is different, depending on certain conditions in atmosphere and time of year, and a whole slew of other abiotic and biotic factors will adjust the carbon balance for any one given ecosystem. But I think the figures are clear enough that given the amount of carbon stored in those forests, we do best keeping them as forests rather than converting them into palm oil or soya plantations.
Thanks. I'm a bit puzzled. You say that climate change is the biggest threat to biodiversity in the future. Yet you also showed some results, I believe, where climate change was responsible for less than 10% of the threat to that biodiversity. So how do these two things...
So are you talking about, so I put up a figure and said that climate change is currently responsible for 7% of population declines. But climate modelling suggests that in future it will be the biggest threat because of its interactions with other threats such as land use change and so forth. So it's it's a complex story. Currently, climate change is only contributing on its own to 7% of current species declines, but all the latest models suggest that in the future, moving forward over the next 50 to 100 years, it will be the biggest source of extinction.
But only because of its interaction with other things like land use through economic activity.
Yeah, largely, yeah.
Right.
So climate change is, you know, the climate of the Earth has been changing considerably over the history of the Earth, but at a much slower rate and at rates that enable evolution and change in behaviour and changes in ranges to accommodate it. But the problem is that given how we've modified the environment, we basically constrain the ability of nature to respond to climate change in that way. So when you build all these layers into these models, you do get these very elevated levels of extinction.
Seems to me that quite substantial changes in let's say, land use have to be made before that kind of contribution is going to be less than climate change.
That's the very point I'm making, isn't it? I mean, fact is, to avoid catastrophic climate change, we need to stop converting our natural habitats into agricultural and industrial wastelands. The two go together. That's why I'm putting these two things, framing it in this way. These are interdependent processes. In fact, all the challenges of the 21st century are highly interdependent and need to be talked about within the same framework, whether we're talking about food security, water security, biodiversity or climate change. It's the same problem and many of the solutions are the same.
Hi there. Hello there. Hello there.
Hi.
Just building on that question about the projections into the future. Now, this field of projecting species distributions has been going on about 10 or 15 years. Mm-hmm. As somebody who's watched that develop, would you say that that's now a mature field, or is there substantial room for improvement still?
I think there's always room for improvements. I mean, we are at a very exciting time in the sense that a lot of big data sets are coming together. We now are bringing together data sets on species traits, on their ranges. We're having much better understanding of how climatic envelopes will change. And I would say that actually there's a room for a lot of maturation in the sense of that some of these climate models need to be made more realistic by incorporating understanding of the biology of the organisms they involve. A lot of those models, for example, assume that all species are equal in terms of their ability to disperse, in terms of their competitive abilities when they arrive at their preferred niche space. And some really exciting work moving forward is saying, well, actually, that's not true. Species aren't equal in those ways, and building these models that can look at these communities as dynamic, and actually possibly some of these future communities just wouldn't be sustainable. So even if the climatic niche is perfect for their physiological tolerances, those communities might not be stable simply because of, for example, competitive interactions being off kilter and so forth. So I think we've a long way to go, but we're right at the cusp of being able to make the models a lot more realistic because these data are coming together, because the mathematics is coming together. So.
Thank you. I was wondering if you had any thoughts about assisted migration and whether this might be more feasible in the future, particularly in the more mountainous areas you were talking about in the beginning.
I don't actually have a view on that, I have to say. It doesn't seem like a top priority. Technologically difficult, potentially very expensive. It might be, to do that for large numbers of species. Eventually will be technically feasible, but I think the costs involved in that would be better spent in other ways in tackling some of these other issues that I mentioned. Sorry. Okay. All right. Okay, thank you very much.
I'm just wondering if you have any ideas about how to make this issue more real for more people, like in the UK, who can't necessarily observe the change and you know, the changes that you're describing in biodiversity. You know, and one of the problems, obviously, with climate change is that it's something that you know people feel very remote from and can't see.
Yeah, I mean, it is an issue. There is a study recently showing that after the big winter floods of 2 years ago, was it? Oxford was particularly badly affected, that there was an instant change in people's attitudes towards climate change, and actually people feeling that it was more real for them. So you're right in pointing out that most people aren't going to be motivated unless it's affecting them directly. And one of the problems that plagues the whole climate change debate is that a lot of influential people in influential parts of the world aren't feeling those changes, or if they feel changes, they see things like cooler winters rather than global warming. So it's a huge issue. But I think I really have a lot of faith in the power, increasing power of things like social media, of all these campaigning organisations, of things like Global Forest Watch, which are making it possible for people in this part of the world to sort of see what's going on. So it sort of was sort of flagged up sort of some of that technology. So it's possible to see what's happening to forests in the tropics, and then it's possible to, through these various different sort of social media or online platforms, to get a sense, and I think, of actually the global nature of the problems and some of these. There's recently the global calculator. There's been like an online global calculator for looking at, you know, for enabling individuals to sort of get a sense of what sort of sacrifices they would need to make in terms of their personal commodity consumption in order to keep climate change within reasonable limits. So there's lots of sort of tools and technologies and interfaces through the internet, through social media, through the media itself. I think that media has a very important role to play. So all those things are very important. Clearly, we can't start advocating everyone, you know, hops on planes to try and go and see some tropical deforestation. But I think there's been a growing movement. I don't know whether any of you have seen there's a Doritos video, which starts off very, very cheesy, but the ultimate message of this Doritos video is that actually a lot of deforestation has gone on in order to bring you your bag of Doritos. And a lot of people, I think, don't realise what the deforestation, the climate, the biodiversity consequences are of their consumer choices. And I certainly would like to live in a world where, you know, when I go into the supermarket and I'm choosing this soap or this cereal or that cereal, there's some clear indication of what the costs to the planet and to people on the planet, both in terms of social conflict and environmental cost, have been. We would all, I assume most of us in this room, would like to have that power, giving us some of that power. And I think those kinds of things are the things that are going to increase engagement and actually make a real difference. Just one more question. Okay. Yeah. Oh, it's okay, thank you. Just one more question, yeah.
Do you think that it's fair to completely prevent, well, hypothetically prevent deforestation in places like West Africa, where having seen a lot of rapid development after oil palm expansion in Southeast Asia and Brazil, or from other regions, it might allow rapid development there?
Yeah, there's a fine balance. A lot of it is unregulated and illegal, and that's what needs to be addressed first of all. Absolutely. I mean, no way can we say, you know, we want to halt development in these places. But it's balancing short-term development with long-term development needs. And actually, for example, you know, there's lots of data suggests now that we are, the FAO have produced various findings lately to suggest that we are actually producing enough food to feed up to 8 billion people. And the problem is one of production, one of distribution and storage. There's some studies that show that if you give agricultural subsidies or power over agricultural subsidies and incentives to local women who do perform most of the agricultural services in Africa, for example, then you massively increase productivity. So I don't think that these two, I think this is quite nuanced and complex, and actually development can go hand in hand with maintaining a very healthy, biodiverse, carbon-rich environment. Okay. All right, thank you.
Okay. So thank you very much, Nathalie. I'd just like to, before we finish, draw your attention to a few forthcoming events. This was the last of our 8-week series on climate change this term. Because it's such a massive topic and this is a big year for climate change, we're carrying on coming at this from more angles every week from the beginning of next term. So that kicks off on the 30th of April with a talk from Professor Simon Caney, who is director of our Oxford Martin programme on human rights for future generations, and that's called Realising Human Rights in a Warming World. And some other big one-off events we have coming up. On the 27th of April in the Sheldonian, we have Thomas Friedman coming, the 3-time Pulitzer Prize winning journalist, I think. His book, The World is Flat, was a huge success about 10 years ago, and he will be talking on The World is Fast. So he continues to be fascinated by all those issues of globalization. And we expect that to be very popular. So if you're interested, please do go on our website and register. That's the 27th of April. We have some philosophers and economists coming together for a panel event here on the 11th of May to try and be a bit more upbeat under the title, We've Never Had It So Good. How does the world today compare to 1957? And the last one I want to draw your attention to, because you're obviously all interested in climate change, we have Connie Hedegaard coming on the 18th of May, Monday the 18th of May. Now, Connie Hedegaard was the host minister at the Copenhagen COP, and she was also responsible at the heart of all the negotiations that led to the creation of the timetable, which is now culminating in Paris. And she was the European Commissioner for Climate Action, but has now stepped down. So she's coming to give a rather more, I hope, personal talk on what it's actually like to be in the middle of all of those sort of climate negotiations. So if you're interested in that, that's on the 18th of May, and again, just register on our website. But I would like to finish with just to thank Nathalie once more for braving her throat to present us with certainly the most beautifully illustrated talk we've had all term. And not only that, but actually trying to offer solutions and even daring to offer optimism and hope. So thank you very much, Nathalie.